Hello.
Good morning. How are you?
I'm good.
Good. Good. How's everything been going so far?
Everything's been good. I'm just trying to figure out what homework goes with what subject.
Exactly. I'm sure. So how many classes are you taking this?
I'm taking Algebra 2 with Miss Steph, and it's so weird to be taking algebra from a different teacher than you. So I'm getting mixed up. I'm like, okay, Miss Steph is my algebra teacher. Okay.
Right. Oh
Um,
my goodness.
and then I'm taking geometry and ACT prep,
Mm-hmm.
and I'm doing literature as well, which is at home.
Okay. Yeah. Well, very good. Very good. So how's Algebra 2 going so far?
Algebra 2 is going okay. I'm just trying to figure out Miss Steph's style.
Yeah, I know. I think that's one of the hardest parts is figuring
Yeah,
out teachers and their style and all that good
yeah.
stuff. I
It's just a
understand
little
that.
bit difficult to process what she wants because she's trying to process what she would normally do in a classroom to
Mm-hmm.
virtual. And I'm like, I don't understand this.
Right. It's a little different. A little
Yeah.
different. I'm going to turn on a little more light.
Okay.
My screen looks so dark. Let's see. See if this will go. Maybe if I open my blinds. It's still just dark in this dining room.
I can turn on a light if I'm too dark.
No, you're great. That's why I was looking at you and I was like, I can see you perfectly, but I
I'm
just look like
sitting
I'm in a shadow.
directly in front of a window.
I look like I'm in a shadow. So
My mom just helped me rearrange my desk to where I have more room to work. And I'm like, it's super helpful.
that's great. That is great, especially, when you're working with it just a little bit here and there, but now that you're completely at your desk
Yeah.
for the time being, I know that's having more space is good.
So I had a question on the geometry homework.
Yeah.
So is the homework due next Wednesday, August 19th? Is that correct?
Yes. So
Okay.
on Wednesdays, that'll be when you'll everything needs to be uploaded.
Okay.
But we'll definitely, if you have questions, you can definitely ask questions before next Wednesday. That's just when it's due to turn in.
Okay.
Okay.
I've also wrote down that it's pages 6 and 7 in the
Uh-huh.
textbook. Correct? Okay.
Yeah, 6 and 7, and we did 2 through 32 evens was what our assignment was for yesterday. Morning, Garrett.
Good morning.
How are you today?
Good. How are you?
Good. So you're back. I didn't run you off. I didn't scare you too bad.
No, I was good yesterday.
Well, good. I never know how it's going to go with the whole virtual thing. So
Yeah.
anyway, did y'all have anything great and exciting happening yesterday, or everybody just kind of relax a little bit?
I mean, it's kind of just a regular Wednesday. Just kind of do school, go to church.
Yeah. Very good. Now, what part of town do you live in?
Kind of Alabaster, Maylene area.
Okay. So you're fairly close to the co-op. I just wasn't sure because we've got some students that are further away, so I didn't know.
It's about a 7-minute drive.
Okay. I've got a sick doggie today, and so she keeps. I hope hopefully she won't throw up in the middle of class. I've already called the vet, and they're supposed to try to call her in some medicine. That's her heart. Yeah, just go lay down.
Our dog gets so freaked out about thunderstorms and rain because there was a one at my grandparents' house that scared him a lot.
Yes. We had a lab that was terrified, and we had him, he was almost 100 pounds. He was a big dog. But we had a thunder shirt for him that we would put on him.
Yes, and she hates it though.
Yes. But Millie's not too afraid of many loud noises. Good morning, Tyler.
Morning.
How are you today?
Good.
Good. Here comes Alec. Oh, there's Alec. Here comes Keely. Good morning, Alec.
Good morning.
How are you today?
Very tired.
I was going to say 8:30. 8:30's been a little rough for me. I don't know about you guys. Oh, I thought I saw Lucas coming in, but he dropped off.
Yo, Tyler, y'all got a scrimmage today?
Yes, sir.
What time?
3:30.
You know if other people can come?
Yeah.
I bet I might have to come.
Morning, Keely.
Good morning.
How are you today?
Doing well. How are you doing?
I'm good, thank you. All right, so Garrett, do you play football too?
Gave it a shot.
So Tyler, you play?
Yes, ma'am.
Very good. Here comes Lucas. And well, no, he keeps dropping off. Well, no, maybe. There he is. Yeah, my son is in 7th grade, so he's just started football this week, and so I'm not exactly thrilled about it, but whatever.
That's
And of
one
course,
I did play JV.
yeah,
Because JV, you don't like practice every day. You just kind of chill.
yeah. All right, 1, 2, 3, 4, 5, 6. Who are we missing? April. We're gonna be missing hopefully. I'll have to check with April and see if she set her clock this morning. Hey, y'all, hang on just a minute. My vet's calling. Oh, April's coming in. Hello. Hey, how are you? That's what I think. She kind of started a little bit of a cough last night. And so anyway, I didn't know if it was just from being boarded or I understand. Right. Oh, absolutely. Right. Mhm. Yeah. Okay. Sure. Okay. Yeah, let's go ahead and do that. Let's go ahead and start something like that, and then that way, if she's not getting better, then we can have her looked at. But let's just go ahead and go that route. That would be great. Oh, Right. Yeah. No. Yeah. Certainly. Okay, that'll be great. Absolutely. Okay, and she also needs to get her heartworm and flea and tick. Can she take those simultaneously, or do we need to wait until she's better from this to take those? Mm-hmm. Okay. Okay. Yeah. Okay. Yeah. Okay, great. Well, if you could go ahead and get those filled for me, those two, as well as the other, that would be great. Perfect. I will. Thank you so much. Bye-bye. Sorry. So for those of you just tuning in, I've got a sick puppy. And so we were at the beach last week and we boarded her. And so evidently she has gotten kennel cough from being there. So anyway, so he was trying to reassure me that we did not need to test for COVID. And I'm like, I'm not having my dog tested for COVID. So I was like, no need for that. Just give her some medicine for the cough. We'll be good. So anyway, all righty. So sorry for my delay. I think we've got everybody now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Yeah. And then obviously, like I said, Easton will be joining us next week after I worried to death about him yesterday. But anyway, okay, well, we'll go ahead and get started. And first of all, we'll start off, if you have gotten started on your homework, does anybody have any questions so far about any of the homework or about the due date or anything like that? Oh, sorry. Tyler?
I looked on the website to go ahead and turn it in, and there, do we do it for yesterday's date or next Wednesday?
Okay, so you'll turn it in for next Wednesday. I need to go in, that reminds me, I need to make a note to delete, because I think I had put in two dates for homework. I need to delete the Thursdays. Delete Thursdays. Okay, so yeah, and also the other thing is you'll see that there is one where it says effort and one for accuracy. You only have to upload it to the effort tab. You don't have to upload it to both because what I'll do is once you've uploaded it in the effort tab, I'm going to pull it out of there and then I can grade it and then I'll just put the score in for accuracy. So you only need to upload it to the effort one for whenever you're turning in homework. And I've got this weird hair that keeps sticking up on us. Anyway, all right. So so any other questions about that? Thank you for mentioning that. Garrett, did you have a question?
I was about to ask what Tyler did, but
okay. Okay. Yeah. So for those of you that have had me before, it's the kind of thing where a lot of times I'm a little scattered. And so I was so proud of myself for actually getting dates put in ahead of time this time. But then I ended up changing it. So I've done all that stuff and I ended up changing it. So I got to mess with it again. But anyway, so yeah, I'll get in there and I'll delete all the Thursdays. The homework that we have yesterday and today will be due next Wednesday. So that's what, the 19th. So that'll be the date that you upload it, and you only have to upload it to the effort tab. Okay, is that good?
Yes, ma'am.
Awesome. Okay, so 6 and 7 was where we had homework from. Any questions on that so far? All righty, and then so now what we'll do is we will back up a minute because we had stopped on page 4 dealing with counterexamples. So I'm going to go ahead and bring up, let's see, y'all. Need to share my screen. And then I need to go to Notability. All right, and this is where we left off on page 4, dealing with a counter example. So the prefix counter, a lot of times you can kind of think of like if you're maybe you're trying to negotiate something with a parent. My son recently, his thing is trying to negotiate for fishing poles and new rods and reels, and for some reason we need like 10 of them, which I thought you only needed 1. But he's always, so whenever I'll say, okay, we'll do this, then he always comes out back with a counter offer. He comes back with, hey, well, what if we do this? And so when we're talking about countering, it's talking about going back and forth and kind of changing things or showing a different side of things. So that's what we're looking at here when we have a counter example, okay? We are finding an example that, that shows that the conjecture is false. And remember, we talked about that a conjecture is basically like making a prediction or making a conclusion on something happening. And so starting with example 4, it says, show the conjecture is false by finding the counterexample. All right, and so the conjecture that they've said here is that for all real numbers x, and I'll make a little note right here. Let me get my pencil going. We're right here. Okay, so the conjecture says for all real numbers x, the expression x squared is greater than or equal to x. Okay, so let's think about that. So basically what we're doing is we're thinking about, well, hey, if I had 1 squared is 1, and that would be equal to x, so that would be an example. But what they've done is they have shown us that this conjecture is false, and we can see why. And it's because if I have a decimal squared, and we can see the conjecture is false, if we have 0.5 squared, when I do 0.5 times 0.5, that ends up equaling 0.25. And 0.25 is actually less than 0.5. 1/4 is less than 1/2. So any number that is going to fall between 0 and 1 is going to give us a counterexample. If I have a decimal number, so it could be like 0.7 squared, 0.725632, whatever number you wanted to put that would fall between 0 and 1 would end up providing a counterexample. Okay, so so let's go ahead. On page 5, it says not every conjecture is known to be true or false. Conjectures that are not known to be true or false are called unproven or undecided. So sometimes we're going to have things that are very clear as far as true or false. Okay, we're going to know for sure that something is true, something is false. But sometimes it may be an undecided thing. It may be something that we're not quite sure of. And so we'll be kind of looking at examining an unproven conjecture. All right. So example 5, it says examining an unproven conjecture. In the early 1700s, a Prussian mathematician named Goldbach noticed that many even numbers greater than 2 can be written as the sum of 2 primes. So again, whenever we're hearing these mathematical words, just stop and think about, what do I know? I know sum means adding. Primes, think about prime figures, prime numbers. Always my smallest prime number is 2. So we've got 2, 3, 5, 7, 11, so on and so forth, okay? So it shows that even numbers could be written as the sum of 2 primes. So we can see that 4 can be written as 2 plus 2. 6 can be written as 3 plus 3, 8, 3 plus 5, 10, 12, 14, 16, 18, and 20, and so on and so forth, okay? So the conjecture is that, hey, an even number greater than 2 can be written as the sum of 2 primes. And it says this is called Goldbach's conjecture. No one has ever provided that this conjecture is true or found a counterexample to show that it is false. As of writing this book, it is unknown whether the conjecture is true or false. Why do you think that is? Why do you think that they haven't been able to prove it as true or false? Any ideas? Look at the next sentence. It says, it is known, however, that all even numbers up to 4 times 10 to the 14th power. 10 to the 14th power is a humongous number. So the reason they can't provide that it's true or false is because they have not been able to do this. They have not been able to add these together to make, because we have an infinite number of numbers. Okay, so think about that number line is infinite. So there are still prime numbers that are massive numbers. Okay, so that's what it's saying, that that they've gotten up to 4 times 10 to the 14th, but because it keeps on going, they can't prove that it's true or false because they haven't been able to multiply. I mean, they haven't been able to go that high with the numbers. Example 6 says using inductive reasoning in real life. So sometimes we have situations that we may use our inductive reasoning in real life situations. So it says a full moon occurs when the moon is on the opposite side of the earth from the sun. During a full moon, the moon appears as a complete circle. So you can see when it's a new moon, basically you're not seeing anything. You've got the waxing crescent, the first quarter, the waxing gibbous, the full moon, waning gibbous, last quarter, and waning crescent. So it says using inductive reasoning in the information below, sorry about my dog, oh my goodness. Using the information below to make a conjecture about how often a moon occurs. Millie. So basically, we know that pattern. We know that after the new moon is going to be the waxing crescent. After the waxing crescent will be the first quarter. We use inductive reasoning to say after this is going to be this, and we see that pattern happening over and over and over again. So we know that once we hit waning crescent, what's going to be coming next? The new moon, okay? And so it says specific cases in 2005, the first 6 full moons occur January 25th, February 24th, March 25th, April 24th, May 23rd, and June 22nd. So the solution is that the conjecture is that every 29 or 30 days, there's a new moon. I'm sorry, there's a full moon. So it says this conjecture is true. The moon revolves around Earth once approximately every 29.5 days. So again, it's the kind of thing where they have to have a year's worth of data to look at this and see, you know, to be able to look, but they have that data showing that every 29 or 30 days, we're going to have a full moon, okay? So it says inductive reasoning is important to the study of mathematics. You look for a pattern in specific cases, and then you write a conjecture that you think describes the general case. Remember, though, that just because something is true for several specific cases, it does not prove that it is true in general. So what we're kind of starting to build up to is in geometry, we are going to be working with things called proofs, okay? So it's where we take the information, we take the general situation, we use our inductive reasoning to say, hey, this is what I think is going to come next. And once I get through these steps, then this is my final step. But we've got to be able to prove it. So that's kind of where we're going with this, okay? So you can see that was page 5, and then we got on to 6 and 7 that we had for our homework. So now what I want to do is go ahead and turn to page 8. Okay, so let's go ahead and page 8. Page 8, we will do our homework on finding counterexamples. So what we're going to do is, we've already said that 6 and 7, we have 2 through 32 evens. On page 8, we are going to do 34 through 38 evens on counterexamples. Then let's go over to page 9. And let's do 60 through 70 evens. Okay, so 6 and 7, 2 through 32 evens. Page 8, 34 through 38 evens. And then page 9, 60 to 70 evens.
Did you say the first one again? The problems?
Yeah, I'll just go ahead and say them all. So page 6 and 7 was what our
Okay.
homework was last night, 2 through 32 evens.
Okay.
And then we're going to do page 8, 34 through 38 evens. So just 34, 36, 38. And then page 9, 60 through 70 evens. Okay.
Thank you.
You're welcome. And now we will move on to page 10. We are starting section 1.2. Alrighty, so points, lines, and planes. If you look over underneath the 1.2, what you should learn, it says our first goal is that we will understand and use the basic undefined terms and defined terms of geometry. So that tells me we're going to be learning some defined terms and some undefined terms. And then it says goal 2 is to be able to sketch the intersections of lines and planes. Okay. So on page 10, our first highlighted word is a definition. It says a definition uses known words to describe a new word. So the key there is we have words that are already known, already proven, and they describe a new word. In geometry, some words such as point, line, and plane are undefined terms. Although these words are not formally defined, it is important to have a general agreement about what each word means. So basically what's happened is there is not a general definition. They consider these to be undefined, but we have to accept what we know about these undefined terms to be able to use them in other definitions in geometry. All right, so the first one is a point. A point has no dimension. It is usually represented by a small dot. Okay, so we all know we've graphed points on a graph, on a number line, things like that. A line extends in one dimension. It is usually represented by a straight line with two arrowheads to indicate that the line extends without end in two directions. In this book, lines are always straight lines. So whenever they talk about a line, it's not going to be talking about a wavy line. They're not trying to trick you. They're always talking about a straight line. Okay. And then, so have you ever heard the expression, the shortest distance between 2 points is a straight line? Okay, so if we've got 2 points, the shortest distance is going to be a straight line. A wavy line is going to be longer. So a straight line is going to be that shortest distance. And so, and then the last term is a plane. A plane extends in 2 dimensions. It is usually represented by a shape that looks like a tabletop or a wall. You must imagine that the plane extends without end, and even though the drawing of a plane appears to have edges. Okay, so like I said, with the difference with geometry versus algebra is we're kind of having to visualize some things that are not concrete images. Okay, so just like a point, it talked about how it has no dimension. Okay, a line has no beginning and no end, so we're having to visualize that those arrows are showing where it extends indefinitely, and we're just kind of having to imagine that. And then finally, a plane is going in 2 different directions, or it has 2 dimensions, but again, it's going to extend indefinitely in all those directions. Okay, because we're trying to draw it on paper, it has to have defined edges, but we have to understand that realistically it extends in all directions indefinitely. Okay, also one of the things about a plane is a plane has no thickness. Okay, so I could stack, like if I stack my hands on top of each other, obviously there's going to be a thickness there, but with a plane I can stack 1,000,000 planes on top of each other and there is no thickness. Okay, so that's one of those things that is kind of hard to wrap your mind around, but it has no thickness. So you can stack them, and that's it. All right, so it says a few basic concepts. Oh, yeah, so we can see the picture of point A. Now, one of the things I want to mention is how they're naming these. Okay, so you can see that when I am naming a point, I can either name it with a capital letter and a dot, or I can name it using the word point and the capital letter A. or I mean, it's not, or whatever the letter is. So the word point and a capital letter is another way to name it. Now, naming a line. If my line has, usually it's going to be an italicized lowercase letter to name a line. So you can see that you can either name it by that italicized lowercase letter, or you can use 2 points that are on the line, 2 capital letters, and you can draw the line above it with the arrows on it. Okay, so that's 2 ways that I can name a line. It can either be used the lowercase letter, or 2 points on the line with the arrow line above it. Any questions about that? And then finally, a plane. Notice here, I've got just a letter in that top corner, and it does not have a point beside it. Okay, so that's telling me that it is naming that plane. All right. So, so that you can either name it by whatever that letter is by using the word plane and the letter, or to name a plane, you have to use 3 points that are located on that plane. So you would call it plane ABC, or whatever letters are on that plane, but those are the 2 ways that you would name a plane. It's either going to be named the word plane and the capital letter that does not have a dot associated with it, or you name it with the word plane and 3 points that are on the plane. Okay? All right, so it says a few basic concepts in geometry must also be commonly understood without being defined. One such concept is the idea that a point lies on a line or a plane. Okay, so it's not in a plane, it's not in a line, it is on it. It's just laying right on top of it. Okay, and so there are a couple of terms that we are going to be using. The first one is collinear points, and then coplanar points. Okay, so collinear, the prefix co is going to mean together. Okay, and obviously linear would be a line. So collinear are points that are on a line together. Okay, coplanar are points that are on a plane together. Okay, so the prefix co means together, and then if I'm talking linear, they're together on a line. If they're planar, they're together on a plane. Everybody good with that? So now what we're going to do is we are going to move on to example 1. Hey, y'all, hang on just a minute. Hey, Joe, I talked to the vet. They have been able to trace that kennel cough back. They were able to trace the kennel cough back, so they're going to call in medicine for us. They said if they do end up having to see her, that they will cover the visit. Well, I mean, it'll be ready at the vet to pick up later. No, we don't have to take her. No, not yet. All right, sorry, little doggy business. All right, so example 1, naming collinear and coplanar points. So letter A says name 3 points that are collinear. All right, so let's take a look at these. If I'm looking at my lines, one of the things I want to tell you though is let's focus on this real quick. Do you see these little dots right here? When I see a picture like this, that is indicating that this will be my very crude. All right. Basically, it's like this plane, like my paper is my plane, and my line is going through it, okay? So that's when I see the dotted line, that means that that is where it's extending below the plane. Can y'all see that okay? It doesn't want to stay up for me, but anyway, so that's what that dotted line means, is that that line is actually cutting through that plane. It is intersecting that plane, okay? So whenever you see those dots, you'll know that that means that that is showing you what it looks like below that plane, okay? So in this situation, we can see that line HE is actually going through the plane, and then line DEF is actually laying on the plane, okay? So let's think about, it says, name 3 points that are collinear. So what are 3 points that are all on the same line?
D, E, and F.
D, E, and F, very good. And then it says name 4 points that are coplanar. What points are all on the same plane?
G, D, E, F.
Yeah, G, D, E, and F. Look at H. see how H is kind of up there on its own? That one is not located in the same plane and is located in a different plane. So it is not coplanar because it's not actually located on that plane. All right, and it says name 3 points that are not collinear. What would just be 3 points that are not collinear?
H, G, and D.
Yes, and I just said something wrong. I just said that H was not on that same plane. It is, because what would happen, that edge extends indefinitely, okay? So again, I've got to think about that. So because it's extending indefinitely, H is actually, it is located in that. It's just on a different line. So it's not collinear, but it is coplanar, okay? So letter C said with the 3 points that are not collinear, it says there are many correct answers. For example, points H, E, and G do not lie on the same line. So I could have H, E, G, I could have F, H, G, I could have D, G, E. There's all kinds of different things that we could use there. Okay, so moving on to page 11. It says another undefined concept in geometry is the idea that a point on a line is between 2 other points, okay? And it says you can use this idea to define other important terms in geometry. What I want to do is this word between, sometimes you'll hear it called the betweenness of points, and that just means that they are between 2 points. Later on, we'll be talking about a midpoint, and that's where it's halfway between 2 points, but betweenness just means that it's between 2 points. Okay, so now it says consider line AB. Okay, so they've got us a drawing over to the right, and we have line AB, and it says it's symbolized by the capital AB with the line with the arrows above it. Now, if we wanted to talk about, when we talk about line, it's got those arrows on the end. Okay, if we wanted to talk about a segment, if we only wanted to talk about this part right here, then I'm going to represent it like this with 2 endpoints. So the main thing between a line and a segment, the difference is a line has the arrows, the segment only has the endpoints. Okay, and so it says, so all points on AB are between A and B. So just because I don't have the dots drawn on that line does not mean that they're not there, okay? So I could have an infinite number of dots on that line between A and B. I can have all kinds of points on that line. I have a huge number of points between A and B there. Now the next thing to talk about is array. An array has an initial point, and then, so one side has an endpoint, the other side has an arrow, okay? So with a line has no beginning and no end, all right? It's indefinite. A segment has a beginning and it has an end. Array has a beginning but no end, okay? So when we name array, we're always going to name it by whatever that first letter is, whatever the letter is by the endpoint. So when I name this one, Ray AB, I would name it with my little arrow on one end and then name it AB, okay? Now, if you look at this one, I would actually name, this one will be Ray BA because B is the endpoint. Okay, so does that make sense about naming rays? You're always going to name it starting with whatever letter is at the end point. Okay, so it says, note that line AB is the same as line BA. So I could name up here, I could call this line AB, or I could kind of let line BA. Same thing here with my segment. This can be segment AB, or it could be segment BA. It doesn't matter with dealing with lines and segments, which one comes first and which one comes next. It does matter with rays, okay? So now we can see, it says they have different initial points and extend in different directions, so that's why it matters. Now right here, it says if C is between A and B, so we're talking about right here, if we have point C between A and B, then you can see that CA is going this way, and then CB is going that way. So those are actually joined by two rays. So two rays put together, opposite rays, form a line. Okay, so those opposite rays make that a line. Everybody good with that so far? I know a lot of this is a lot of definitions and just kind of understanding the drawings and diagrams and stuff, but let me know if you have any questions. All right, so it says like points, segments and rays are collinear, so they lie on the same line. So any two opposite rays are collinear. Segments, rays, and lines are coplanar if they lie in the same plane. Okay, so let's look at example 2. Drawing lines, segments, and rays. It says draw 3 non-collinear points, J, K, and L, and then draw line JK, segment KL, and ray, the LJ. Let's see, it's 9:07, so we'll do our break at 9:20. So we got about 13 minutes before break. Okay, so you can see what they did is it said draw 3 non-collinear points, J, K, and L. So that's what they did here, okay? They could be laid out any way you wanted them to be, okay? They don't have to be in that same pattern. It could be however you wanted it to be. The main thing is they just could not form a straight line because they cannot be collinear, okay? Next, it says to draw line JK. So when you're looking at this, once you've got these in the same thing, you can see where they connected J and K, but L is still out there by itself. Then they said to draw segment KL. So they went from point K to point L, and then draw ray LJ. So then they connected ray LJ. Okay, so sometimes there will be things that one of the things I wish they would have put on here is if they want it in a if you're developing one solid figure, okay. But again, it's the kind of thing where you could have moved, those points could have been in different places, and but the main thing is you would just connect them based on what it tells you to do. Example 3, drawing opposite rays. It says to draw 2 lines and label the points on the lines and name 2 pairs of opposite rays. So you can see the example that they've shown us. They drew 2 lines. Now again, I wish they would have said draw 2 intersecting lines, and then that way you would know that they needed to cross over each other. And so it says draw points on the lines and name 2 pairs of opposite rays. So if we look at this, they named point M and N on this line, but also I've got X. But notice here, when I've got P, X, and Q on that line. So we have point X is actually on both of our lines. So point M, N, and X are collinear. X is between M and N. So ray XM and ray XN are opposite rays. So I can look at this and see that if I'm looking at ray XM and ray XN, those are opposite rays. Also, XQ and XP are going to be opposite rays. Okay. This says points P, Q, and X are collinear, and X is between P and Q, so XP and XQ are opposite rays. Okay, so we can see that. All right, goal 2 says sketching intersections of lines and planes. So when we talk about things intersecting, we know that means crossing over. I'm assuming that most of you, if you have not started driving yet, you're probably close to driving, and that you drive and that you or have at least ridden in a car, and you know what it's like to go to an intersection. That is where our roads are going to cross over. And so a lot of these words, what I like you to do is try to use like some real life examples to help you visualize what they mean. We don't have to have a separate math definition and a separate real world definition. It's going to help you to remember things a little bit better if you kind of let them overlap. So it says 2 or more geometric figures intersect if they have 1 or more points in common. The intersection of the figures is the set of points the figures have in common. So if we're looking at this with intersection, okay, so they're saying if we had 2 index cards And you can see like they've got the picture of one index card, and it's like they end up joining them together to where they would intersect. So you can see where it actually makes the 4 different areas once they've intersected, okay? So let's take a look at those, and we're going to be looking at this figure right here, okay? And I'm going to kind of zoom in on that a little bit, okay? So we can see here that we would have the intersection of AB right there actually intersects with CD. Okay, so those 2 would be intersections. Also, I would have AB is intersecting with EF. Okay, so we can see that those different intersection points. Okay, so it says, what is the intersection of AB and CD? So let's take a look at that. If I'm looking at AB, that one, when I'm looking at AB and CD, what is the intersection point? Does everybody see where it intersects at G? So right here, where this line and this line intersect, it's intersecting at G. Okay. Now it says, what about AB and EF? So AB and EF, what's that intersection point?
G.
Also at G, isn't it? Okay. Now it says slide the cards together. So actually, I'm sorry, that was looking at these figures. Whoop. That was going through looking at these figures, but now we could see it on there as well. Okay, so it says with number 4, sorry, I'd forgotten to turn my actual page. I'm working on my iPad instead of my book. Okay, so we looked at the intersection lines. Let's look at CD and EF. We did that. Okay. And so it says, what is the, and number 3 says, what is the intersection of planes M and N? So what we're looking at is, let me change my color for a minute. I'll make it a little pink. Notice here, this one is plane M, okay? And then when I look right here, that is plane N. The reason I'm naming them plane M and plane N is because these are not actual points on a line. They're just points that are out there, okay? So when I'm looking at, these are 2 separate planes that are intersecting. I have plane M and plane N. So what is the intersection of those 2 planes? When this plane intersects with this plane, where are they intersecting? They're intersecting right here, right? You see that that's their intersection line? And so what line is that? They intersect at AB. So do you see that when I have my 2 cards, they're intersecting right here. That is the point where those 2 intersect at line AB. Is everybody good with that? Like I said, it takes a little bit of change, visualization, kind of seeing things. If you don't see something, let me know and I will do my absolute best to try to help you see it, okay? And then number 4 says, are CD and EF coplanar? So let's look at line CD. So CD and EF. When I've got 2 separate planes that have now intersected, they have actually joined and made one plane, okay? So if they're separate planes, if they are not touching, if they're not joined in any way, they are separate. But if they intersect, so now we could call this plane CEG. Okay, so they intersect and it would be plane CEG would be a way of naming this plane. Okay. All right, so let's go ahead and take a look at example 4, sketching intersections. So sketch the figure described. So letter A says a line that intersects a plane in one point. So you can see this picture that they've drawn here for letter A. They drew a plane, and then they drew that line that goes through at one point, kind of like my pencil example a minute ago with my pencil and paper. If I were to just stab that pencil right through the paper, it's the same thing as if I just put that line straight through that plane, okay? So we have a line intersecting a plane at one point. Then letter B is 2 planes that intersect at a line, okay? So notice what we're learning here is that a line intersects a plane at one point. So when my line intersects a plane, it's only going to be at that point. But 2 planes intersect at a line. Okay? So that's going to be something you need to know. That a line intersects a plane at one point and that 2 planes intersect at a line. All right? So we'll go ahead and just put a little star by this information because that's something that you need to know. A line intersects a plane at one point and 2 planes intersect at a line. Any questions about that? All righty. Okay, so we got just a couple of minutes before break. So let's go ahead and kind of look at this vocabulary check here. So it says, describe what each of these symbols means, okay? So this is my participation time. What is this one telling me? What would we call that?
Segment.
Segment, PQ.
Yeah.
Okay, so we would name that segment PQ. What is this one?
Ray.
PQ.
Ray PQ, great. And this one?
Line PQ.
Q.
Line PQ, and this one?
Opposite
Ray
Ray QP.
QP.
Good. We opposite Ray QP or just Ray QP. Good job. Good job. So understanding what those symbols mean, how to call it by the name. All right, so sketch a line that contains point R between points S and T. Which of the following is true? So let's go ahead and do this. I'm going to go ahead and sketch a line. And they said it's going to be R is between points S and T. So that means I'm going to have point S and point T, and then R is going to be between them. Okay? So it says, is Ray SR the same as Ray ST? Take a look at that. If I have Ray SR or Ray ST, are those the same?
No.
Now remember, I'm drawing them differently. Actually, let me do this for a minute. Okay. If I had Ray SR, think about this would continue out indefinitely, right? But if I called it ST, now can you see it?
Yes.
They're the same, aren't they? Okay. I could name it's the same Ray because my endpoint is S. Remember that because this is the arrow end and it extends out indefinitely, that even if it was SR, that line's continuing that way. But even if it was ST, it's going to overlap and it's going to be exactly the same. Okay. Is everybody good with that? All right. Let's go ahead and take a 5-minute break and we'll come back and keep working. If y'all have any questions during this time, please let me know. Keely, are you good for a little bit, or are you going to be going?
Yes, ma'am. I'm actually, we were supposed to leave, I think we're supposed to leave at about 9:30ish, so
Okay, yes.
I'll be leaving in a few minutes, but
Okay.
I'm gonna try to set up the computer in the car and see how that goes. Hopefully I won't get like dizzy, like looking at the cars
Yeah, so-
behind me.
Yeah, so it's the kind of thing that what we'll do is once you pop back in, I'll admit you back in, and then if
Okay.
you have too much trouble, don't stress about it. I will send you the link for the video that you can watch later, okay?
Okay, thank you
And
so
y'all have a
much.
safe trip, and good
Thank
luck with
you.
everything. All right?
Thank
See you
you.
in a bit, hon.
Okay.
All right, we'll go ahead and get started back. Claire Jane should be back in just a minute. All righty. So we were working with that same line. So for number 2, we're still dealing with this same line that has it's ST with R in the middle. We just looked at the fact that SR, that Ray SR and Ray ST are the same. So now let's look, and it says letter B is line SR the same as line RT. So again, if I were to have line SR, and I had my 2 points, and I go that way, and then I would do line RT.
I need your consent on a few items to continue.
My phone, I don't know why it thinks I'm talking to it. But anyway, are these the same? Yeah, okay. All righty, letter C. Is Ray RS the same as Ray TS? So let's take a look at this. If I have Ray RS, so I would have my endpoint is R, and it's going this way. And then Ray TS, I would have my ray here, and then going this way. Are these the same?
No,
No.
Why?
because one's longer than the other.
Yeah, one's longer. They have different endpoints, don't they? They have different endpoints. So good, they are not the same. All right. Then it says is ray RS and RT opposite rays. So RS going that way. And then well, I guess it doesn't make sense to go over it in yellow again, I think. And RT. Are those opposite rays? And obviously y'all know that, like, realistically they should be straight lines, and me writing on an iPad is not going to be the most perfect. I guess I can, there's a way that I can make it straight, but all right. Then we have segment ST. So that means I have endpoint connected. Is that the same as segment TS? Are those the same?
Yes.
Yep. And then F, ray ST. So start at S, and then it extends through T that way. And is the same as ray TS. So TS here and going that way. Are they the same? No. And I can look at those and tell that they're not the same, because when I look at this one, S comes first and then extends indefinitely toward T. And in this one, T comes first. So I can look at that without even really having to think about it, okay? So hopefully by kind of looking at these, by drawing them out, by seeing them, it's gonna help you develop that ability in your mind to be able to look at it, but also to make the connection about the way that these things are named, and looking at them on a line. All right, so now it says skill check. Decide whether each statement is true or false. So if we look on, look in here, it says points A, B, and C are co-linear, okay? So I have point A, B, and C. What is my definition of collinear? They all have to be on the same line. So are these collinear?
No.
They're not on the same line, are they? A and B are together, but C is not, so this is going to be false. Points A, B, and C are coplanar. Are they all on the same plane? Yes.
Yes.
So that will be true. Point F lies on plane, I'm sorry, point F lies on line DE. So let's look. Here we've got line DE. Is point F on that? No. So that's false. Then it says line DE. So let me just back up my Oh, no, I don't want to do that. So we said that one was false. Line DE lies on plane. We'll just do that. There we go. So DE is what we're talking about. So that's going to be here. And does it lie on plane DEF?
Yes.
Because remember we said naming a plane, you have to name at least 3 points that are located on that plane, and D, E, and F are all located on that plane. All right, what about line, nope, we said that was true. Line BD and line DE intersect. So let's take a look at that. Line BD is going to be here. And then line DE will be there. Do those intersect?
Yes.
Yes, at what point?
Point D.
Point D. So notice if this is my intersection point right here, notice that they both have a D in the name. So by knowing that they're 2 lines and they both have the same letter in it in the name, I know that they're going to intersect. Okay, so that one, no, cancel. So that is true. Line BD is the intersection of plane ABC and plane DEF. So let's look at that for a minute. Let me erase all this. Okay, what is the only thing touching each of these planes?
The line BDE.
The
I mean,
line,
BD.
yeah, line BD is the only one that's touching both planes, right? So do these planes intersect?
Yes. The planes don't intersect, but the lines do.
The lines and the line intersects with both planes, but remember, what did we say? That 2 planes, when they intersect, what do they form? They have to form a line, right? And so these are not intersecting planes, okay? So that is going to be false. Okay? Everybody good with that? Everybody kind of understanding and following pretty good? Okay, so now we're moving on to some more homework, practice and applications. The first section on page 13, starting with number 9 through 16 are going to be true, false. 17 through 24, you're naming a point that is collinear with the given points. And then 25 through 27, it says name 3 points in the diagram that are not collinear. So first we're looking at collinear, then we're looking at not collinear. If you turn the page to 14, name a point that is coplanar with the given points. So it tells us, hey, what is coplanar with these points? Let's look at this for just a minute. Let's look at number 29. Okay, so it's the kind of thing where, again, if you have to actually circle and things like that, I don't know how y'all are about writing in books. I mean, since it's yours, whatever. But anyway, so it says D, C, and F. So what I'm going to do is I've got D, I've got C, and I've got F. So now I can see that I'm focusing on that section right there. So what would be another point that would be coplanar?
G.
G, yeah. So G is a coplanar point. So we can see that this right here is a plane. This right here is a plane. This right here is a plane. So basically, these are 6 planes that have been put together to form a box. Does that make sense? So these are 6 intersecting planes. They're all intersecting at lines, okay? So that's what you're going to be thinking about there. So we have coplanar again, and then non-coplanar. Completing definitions. And so,
Are we doing all the even numbers?
we will be doing evens, yes. So let's go ahead and start. So this will be page 13 is where we're going to start on this one. Page 13, we will have 10 through 26 evens. And then page 14, 28 through 54 evens.
One thing. Do we write the answers in the book? Like the answers to the problems?
Huh? Are you saying like you just want to write in your book instead of writing it on a separate sheet of paper? I mean, that's fine. All you'll need to do is take pictures and upload the picture.
Okay.
I mean, either way, you've still got to turn something into me. So, I mean, it's the kind of thing where if your parents are not wanting to resell the book, then, you know, that's between you and your parents, whether you're going to write in the book or not. Okay.
I'm sorry, which questions again?
He was asking, could he just write the answers in the book? And so
No,
I just said, you know, if you're not planning on reselling the book, then that would be fine. But that would be a conversation for you to have with your parents. So.
Okay.
And then, so that was 354, completing definitions. And then let's do page 15, 56 through 66 evens. And that'll be it for this one.
Did you say any homework before that?
So what I said for this section is page 13. Actually, it's 13 through 14 would be 10 through 54 evens. And then page 15, 56 through 66 even. So realistically, it would be 13 through 15, numbers 10 through 66 evens. I know that seems like a lot, but a lot of these answers are just true, false, or writing a letter or something like that. So it should not take very long whatsoever going through this.
Yes, ma'am.
All righty. So now we are going to move on to page 17. All right, so page 17, this is section 1.3, segments and their measures. So you can see here where it says goal 1, using segment postulates. So we're going to talk about what a postulate is first of all. And so it says in geometry, rules that are accepted without proof are called postulates. Oh, let me let Keely back in. Hey, hon, you back with us?
Yes, ma'am.
Okay. Well, if you're able to follow along, that's fine. But if it makes you feel yucky in the car, you know, it'll be fine. All right. So
Yes, ma'am. Thank you.
I gave the assignment for what we just wrapped up, and so what I'll do is I can. Do you want to write it down now, or do you want me just to email it?
I'm sorry. Could you say that one more time? I was having trouble hearing you.
That's fine. I just said what I'll do is I will email you the assignment that I just gave for that last section, and now we're moving on to page 17, section 1.3.
Sounds great. Thank you.
You're welcome. Okay, so segments and their measures, dealing with postulates. It says we just talked about how rules that are accepted without proof are called postulates. So these are things that, again, like the, now I've lost the man's name. Let me find what his name was. A little Prussian mathematician. Where'd he go? That was with our counter example, wasn't it? So like the, where was it? Goldbach's conjecture, okay? Just like Goldbach's conjecture, it's the kind of thing where we think it's true, but it hasn't been completely proven true. That's kind of what these are. These are postulates that that they haven't been proven true, but we accept them as true. So that's one of the things that we want to know about postulates, okay? So what I'm going to do is I'm going to make a note that these are accepted as true without proof. Okay, and you'll see the words postulates and axioms interchanged, means the same thing. Okay, so just know that if you see the word postulate or axiom, these are the same. Now it says rules that are proved. So if it is something that has been proven, they are called a theorem. Okay, and we use postulates. We use some of this unproven but accepted to be true information to define theorems. Okay, so kind of, let me draw this little flow chart for you. Okay, so you remember in the beginning we talked about our undefined terms. Whoop, go away. Undefined terms we use to form postulates. And then we're going to use those postulates to form theorems. Okay, so that's why we've kind of talked about these. The undefined terms, we have to understand point, line, and plane. We have to understand those three terms because we're going to be using those in postulates. And then we're going to be using postulates to help us make theorems. All right. So here we have postulate 1. One of the things that I'm going to recommend, like I said, I highly recommend that if you keep a notebook of vocabulary words, if you just kind of write down the words, and then that way as you're studying, you're just looking over the words instead of having to flip back through your book. That is going to be very helpful to you. But again, this is going to be something that you would do on your own. Keep a notebook of your vocabulary terms, and then also start a notebook of postulates and theorems. Okay, so then that way we'll have a concise list. And you know what I may do? I may try to type something up and then help us kind of have a running list. I may let me make myself a note to do that. And then if I can be as good as Miss Mitzi is phenomenal about, if y'all have ever had her for class, she can multitask and she can do all kinds of things. Maybe if I can get as good as her, I can actually start a document that I can be typing into as we're doing class. That's my goal, okay? So what I'll do is I will get it started today, and then hopefully if I can pull it off, that way we can have that list and I can email it to y'all each day or whatever, and y'all have a copy of it, okay? So then that way that's a little less work off you guys. All right, so postulate 1 is our ruler postulate, okay? And so it says that the points on a line can be matched to matched one-to-one. When we talk about one-to-one correspondence, we're talking about for each little segment of space is increasing by 1 number. That's what we're talking about. So it's matching up, each little space is matching up with a real number, okay? The real number that corresponds to a point is the coordinate of the points. So then it says the distance between points A and B, written as AB, is the absolute value of the difference between the coordinates of A and B. So remember we talked about absolute value, and we talked about how when we kind of picture our number line, and we know that the distance from 0 to 3 is the same as the distance from 0 to -3. Distance is always positive. I cannot have negative distance. So when I talk about distance, I'm thinking absolute value. So I need to start joining these ideas together to understand them together. So distance, a length, we're going to be dealing with absolute value here, okay? So when we talk about the ruler postulate, that's what we're kind of talking about here, is when we're looking at the distance between one and another, then basically I can subtract. I can look at the distance between them by subtracting them. Does that make sense? Okay, so now we're moving on to example 1. It says find the distance between 2 points. It says measure the length of the segment to the nearest millimeter. So what they did is they gave us a millimeter ruler, and it says use a metric ruler, align 1 mark of the ruler with point A. then estimate the coordinate of B. For example, if you align A with 3, so I'm going to zoom in a little bit here so we can see this a little bit better. So they said, okay, we have aligned A with 3, and then B, they said it's about 5.5. Okay? So we can say that A is 3, B is 5.5. So then what I'm going to do is I'm going to subtract point B minus point A. Okay? So 5.5 minus 3 would be the absolute value of 2.5, and the absolute value of 2.5 is going to be 2.5. So either way, it doesn't matter. You just always want to start by subtracting larger minus the smaller when you're finding distance, because since it's dealing with absolute value, it doesn't matter. It's always going to be positive. So you're just finding the difference of the two numbers. So it says it doesn't matter how you place the ruler. For example, if the ruler in example 1 is placed so that A is aligned with 4 and B is aligned with 6.5, you're still going to find the difference is 2.5. It's still going to be 2.5. So it doesn't matter if you aligned A with 1 or if you aligned A with 6. However, it's still that distance is still going to be the same. All right, moving on to page 18. It says when 3 points lie on a line, you can say that one of them is between the other 2. This concept applies to collinear points only. So they can only be between if they're on the same line. Makes sense, right? That they can only they have to be in a line for one to be between 2 others. For instance, in the figures below, point B is between points A and C, but point E is not between points D and F. So betweenness is what we're talking about here. And betweenness, it can be located anywhere between those 2 points. It doesn't have to be in a certain location. So when this was postulate 2, which is the segment addition postulate. So what this says is that if B is between A and C, then I can add AB plus BC and get AC. There's going to be a lot of letters talking here, okay? So it will be very helpful, make sure you're following along with the diagram, because when you hear me saying AB plus BC equals AC, it's kind of like, okay. But I know that if I have AB plus BC equals AC, then I know that B is that point between them, because I've got B in both of my segments, okay? All right, so example 2 is finding distances on a map. Use the map to find the distances between the 3 cities that lie in a line, or lie on a line, not in a line. Okay, so it says using the scale on a map, you can estimate the distance between Athens and Macon, and this is in Georgia. So you can see that from Athens to Macon, they're calling that AM, and that's 80 miles. The distance between Macon and Albany, or MB, is going to be 90 miles. So if I add 80 plus 90, I get 170. So I can see that if I add Athens to Macon plus Macon to Albany, that makes up Athens to Albany. And so I have a total of 170 miles. So it says the segment addition postulate can be generalized to 3 or more segments as long as the segments lie on the line. So basically, like we said here, we're dealing with 3 or more segments. We're having one segment plus another segment makes a third segment. Okay, but then we could put a whole bunch together to have a whole string of them if we wanted to. But the main thing to understand is that when I add 2 segments together, then I can basically start naming it by that beginning and the end of the other one. Okay, any questions about that? All right, goal 2 is using the distance formula, and you might remember this from the end of last year. We had the distance formula is where we are going to take the square root of the difference of the x coordinates squared plus the difference of the y coordinates squared. Okay, so we are going to be using this formula for the distance formula. We can use this when we're looking at points on a coordinate plane. So remember when we have ordered pairs, we have x and y. So basically, A is going to be point x1, y1, and B is x2, y2. So these are our 2 different points. We just plug them into the formula. Okay, so let's take a look at our example here. Example 3, using the distance formula. All righty, so it says find the lengths of the segments and tell whether any of the segments have the same length. So if I'm looking at A, B, okay, if I have point A and point B, I know that point A is going to be -1, 1, and B is -4, 3. So what I'm looking at here is when I plug this in, I want to go ahead and rewrite my formula real quick. So here I'm going to have AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So now I can see that this is x1, y1, and this is x2, y2. So when I'm using this formula up here, my x1 value goes in here. x2 is going in here. Okay, so that's what this is right here. They have plugged in the values for point A and point B, and then we do the math. Okay, so let me take those out. Okay, so you can see that they've plugged in -4 for x2 minus -1 for x1. Now this is where I have to pay close attention to my positives and negatives, and working with exponents and things like that. Okay, so when I look at -4 minus a -1, remember, -4 minus a -1, remember I can change this to plus a positive. I can add the opposite. So -4 plus a plus 1 or minus a -1 is going to give me -3 squared. And then 3 minus 1 gives me 2. So then I have 2 squared. Notice that I've got -3 squared. So -3 times -3 is +9. 2 squared is 4, and 9 plus 4 is 13. So my solution is the square root of 13 is the distance from point A to point B. All right? So all I've done is plug in the values for A and B into that formula. Then I would use the same formula for AC, the same formula for AD. So we can see when we get to the end that AB distance is the square root of 13. AC is the square root of 17, but AD is also the square root of 13. So we know that those are the same length because they end up having the same distance. Is everybody good with that? I always recommend starting out with the blank formula, just so that way it's easier to see, to plug things in and make sure you get them in the right location, okay? All right, so this says that segments that have the same length, so AB and AD are what we would call congruent segments. All right, the word congruent is going to mean same length, okay? So congruent segments have the same length. For example, for instance, in example 3, AB and AD are congruent because they're both the square root of 13. And so this is our symbol here for congruence. It's kind of like an equal sign with one little wave on top of it. Okay, so that symbol means congruence. So when we see this, this is equal to. Obviously, we're very comfortable with our equal sign, but if we're talking about congruence, we're going to have the equal sign with the wave on top of it. Okay. Now it says the distance formula is based on the Pythagorean theorem. This was another thing that we worked with at the end of algebra last year, Pythagorean theorem. This is where we have a squared plus b squared equals c squared, and this pertains to right triangles only, okay? So what I want to do is we're dealing with Pythagorean theorem. This is dealing with right triangles. Okay, and when we're talking about, and it can be a squared plus b squared equals c squared, or you can write it like this where you have c squared is equal to a squared plus b squared, okay? Same thing, because the c is by itself on one side of the equal sign. It doesn't matter. The main thing that matters is that this is going to be called a leg. This is also called a leg. So we have a short leg and a long leg, but this is the hypotenuse. Okay, so the main thing is the hypotenuse is always opposite the right angle. So that's how I always know. It doesn't matter which one I call A and which one I call B, but it does matter which one I call C. And the way I decide which one is C is because that's going to be the hypotenuse, and the hypotenuse is directly across from the right angle. Okay? All right, so using the distance formula, where we can look at our distances here, I can apply that to the Pythagorean theorem. So let's go ahead and take a look at example 4. And with example 4, it says I'm dealing with a map. And on the map, the city blocks are 340 feet apart going east to west and 480 feet apart going north to south. All right. So it says find the walking distance between A and B. All righty. So let's take a look at this. And what I want to do is whenever I'm dealing with my shapes, okay, what I want to do is okay. Hold on a second. Let me, on the map, the city blocks are 340 feet apart going east to west. Okay, so that is going to be going along our x-axis. Then when it says that they are 480 feet apart going north to south, that's going to be along our y-axis. So thinking about our coordinate grid, the x and y axes, okay? So it says to find the distance between A and B, and then find the distance. Okay, so let's start there. So letter A, if we were walking from A to B, you would have to walk 5 blocks east. You'd have to go 1, 2, 3, 4, 5. And then you would have to go 3 blocks, 1, 2, 3, north. Okay? So we can see how we would have to walk to get to those points. Okay? Because we're dealing with city blocks. So think about this for a minute. So with it being a city block, I couldn't just walk diagonally through buildings. Okay? So that's why that's what we're talking about here. I can't just go from A to B, because that would be crossing through buildings and stuff. If I was actually dealing with a town, I'm having to go along the streets. So I've got to go 5 blocks east, and then I've got to go 3 blocks north. Okay? So that's what they've shown us here, is I'm going 5 blocks and then 3 blocks. Now, it says that if each block is 340 feet apart going east to west, then I've got 5 times 340 is 1,700 feet. Okay, so here I know that that distance is going to be 1,700 feet. 3 blocks that are 480 feet apart are going to be 1,440. So going this way is 1,440. Is everybody following so far? So basically what I've done is I've been able to create a right triangle on this map. And now I can see that I've got 1,700 going this way and 1,440 going this way. So if I use my Pythagorean theorem, a squared plus b squared equals c squared, then I can plug in these values, all right? So it says the walking distance of 1,700 plus 1,440 is 3,140 feet. So that would be your walking distance here. We would just add these two together. So that would be your walking distance. Now for letter B, it says, well, okay, well, that's great if you knew that you walked 1,700 this way and 1,440 that way, and you're walking 3,140 feet. But now it says, what if I want to find that diagonal? What if I want to find the distance from A to B directly? And this is where we would set up the Pythagorean theorem, where we would have that from A to B, okay? So that would basically be what we're calling our hypotenuse. That's our c squared is equal to a squared plus b squared. Okay, so we're calling this A, this is B, this is C. So c squared is equal to a squared plus b squared. We're dealing with some really big numbers here. So we found that 1,700 squared plus 1,440 squared is going to be a total of 4,963,600 feet, which would be approximately 2,228 feet when I took the square root of it. Okay. This one is a little more with bigger numbers and more of a challenge than what we're going to be dealing with on other problems. So don't let that kind of go, oh my gosh, I'm never going to be able to figure this out. Just a squared plus b squared equals c squared. Knowing that when you have a diagonal on a coordinate grid, you can always turn it into a right triangle by connecting, by going either right or left and then going up or down to make it into a right triangle. And so anytime I have a right triangle and I know the measure of two sides, I can always find the measure of the third side, okay? So let's go ahead and take a look at guided practice on page 21. All right, so what did we say a postulate is?
Rules accepted without proof.
Yeah, it's going to be a rule that's accepted without proof. It's something that we go ahead and say that based on the information we know, that it should be correct information, but it may not be. But we don't. It has not been proven true, but we accept it to be true. All right, then it says draw a sketch of 3 collinear points and then label them. Then write the segment addition postulate for the points. So let's think about that for a minute. Okay. Draw a sketch of 3 collinear points and then label them. So what I'm going to do is I'm going to have a point and a point and a point. So I'm going to go ahead and draw that. Obviously not perfect. And I'm going to label them. Typically we're going to, you could label them whatever letters you want to. RST, MBQ, LPN, whatever you want to do. I'll just be fun and call them ABC. All right. So then
Consent on a few items to
there's something I'm saying whenever I say something about that it's triggering my phone. Okay, so we drew the sketch and then label them and then write the segment addition postulate for the points. So that means what I'm doing here is if I have AB plus BC, what is that going to equal?
AC.
AC, good. Very good. Number 3 says, use the diagram. How can you determine BD? So it's saying, how can you determine BD if you know BC and CD? So how could I figure out what BD would be if I knew what the values of BC and CD were? What would I need to do to those 2 segments?
You would add those 2 segments together.
Just add them together, okay? And it says, what if you knew AB? What if I knew AB and AD?
You would subtract A.
Yeah. Okay, so in that one, I know that AB plus BD is AD. So BD would be equal to AD minus AB. So by understanding that when I add them together, it makes a bigger thing, I can use the opposite of addition, which is subtraction, to know that I can take the whole thing and subtract a part to find another. Okay, good job. All right, so let's go ahead and take a look at 4 through 9, finding the distance between 2 points. Okay, so this is where we're using our distance formula. And actually, I tell you what, we are almost out of time. So let's go ahead and, no, we get out 10:15, right? Okay. Okay, so right here, distance formula. So I'm going to have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to plug in 0, 0, and 5, 2. So I'm going to have equals the square root of. If you need to label these as x1, y1, and then x2, y2. So x2 would be 5 minus x1 is 0 squared plus y2 is 2 minus y1 is 0 squared. Simplify that. 5 minus 0 is 5 squared plus 2 minus 0 is 2 squared. 5 squared is 25 plus 2 squared is 4. So this ends up being the square root of 29. If I could simplify it, I would, but if I can't, I'm just going to leave it as a radical, okay? Let me just go ahead and erase that, and I'll use that same workspace. Because I do want to do number 5 before we go. So let's look at number 5. Erase. There we go. Okay, so number 5, we'll have x1, y1, x2, y2. So we're going to plug them in. x2, let me get this. x2 is 8 minus x1 is 3 squared plus y2 is 10 minus y1 is 0 squared. 8 minus 3 is
5.
And 5 squared is
25.
25 plus 10 minus 0 is 10, and 10 squared is
100.
100. So now I have the square root of 125. Okay, I need to break that down. I cannot leave that. That is not in simplest form. So this is where I'm going to have to think about breaking things down. My smallest prime factor is going to be 5. And 5 times 25 is 125. My smallest prime factor of 25 will be 5, and that's going to be 5 times 5. So basically what I've done is I've broken 125 into prime factors, 5 times 5 times 5. I know that I've got to have 2 to come out as a whole number 5, and then the guy that's left under there stays as a radical. So for number 5, I had to simplify my answer to be 5 times the square root of 5. Okay? If you're stuck, if you're still having trouble with simplifying radicals, if you're not quite sure about that and you need help on that, please let me know, and we can do a one-on-one Zoom, and I can kind of help you through that if that's something you need help with. Okay. So what we will do is, let's go ahead and stop there. And on page 21, I just want you to finish the guided practice. So on 21, we've already done 1 through 5. So you're going to do 6 through 12. And that's going to be using the distance formula. Okay, that's going to be practicing with that. And then we will pick up the rest of 21 next week.
Do we do all the even numbers?
So on this one, you're going to be doing 6 through 12 all on the guided practice.
Okay.
Okay, so you're just using the distance formula and finding the solutions. If it's a radical, simplify as much as possible. There will be a couple of them that you'll get like actual real numbers. Okay. All righty. So what I will do is later on, I will, and also one of the things I want to mention, I feel kind of goofy saying this, but I have a YouTube channel, and it's not, I mean, it's just to post lessons. I feel like my son that has like a fishing YouTube channel. But anyway, so I've got the YouTube channel. So I think most of you guys hopefully know where it is. What I'll do is I will email out the links for videos. And then that way, I think y'all have to tell me if you can't get to it. I think I have it set up where you should be able just to go to my YouTube channel and find any of our lessons and be able to watch them. So then that way, if you miss a lesson or if you need to go back to something, you can. So just know that the videos will be posted in the YouTube channel, and I will email out that, as well as I'll start our little sheet with all of our definitions and things. And I will email out this concise list of homework, since I know it's a lot. Okay, since I know there's a lot there. Hopefully it won't take you too terribly long to do it. Just don't put it off till last minute. Remember, it's due next Wednesday. And I hope everyone has a great rest of the afternoon. If you have questions, please don't hesitate to let me know. Okay? Good work, guys. I'm proud of y'all for staying focused and everything. I know it's not the easiest thing, but y'all are doing a great job. And so, I will see y'all next week.
Yes,
All
ma'am.
right. Bye, guys.
Thank you, Miss Jennifer.
Thank you. Have a safe trip, Keely.
Thank you.